at this thing any longer than you have to be. So here's an outline of the presentation, really. Market structure analysis, which is understanding what's the difference between perfect competition, which is the chapter we're on right now, and a little bit of other kinds of market structures, like monopoly would be an example. Then we're going to talk about how firms decide how much to produce in the short run, and then we're going to talk about what happens in the long run. Some more objectives at the end of the chapter. Hopefully you'll be able to name the primary market structures, describe their characteristics, define a competitive market, so you should know what it looks like, understand the assumptions that underlie it, and then compare and contrast. That means what are the similarities, what are the differences between the short run and the long run in competitive markets. Some more objectives: understand what causes a firm to maximize profits, when you might want to minimize losses but not literally go out of business, and what would cause you to completely shut down the plant, sell everything off, and that's it. We're also going to talk about how you get the short-run supply curve for a firm, and then we're going to use that short-run model to determine long-run equilibrium. And the last thing I want to talk about, or this chapter will talk about, is why competition is in the public interest. So, grocery markets, right? Very little variation in price for the same type of fruit or vegetables across different sellers. Part of the reason for that is that in a produce market, like if you ever go to a farmer's market, you see pretty much, if you're talking about the same kind of fruit or the same kind of vegetables, you see everybody selling for basically the same price, and that is kind of the idea behind a perfectly competitive or purely competitive market. Product's all the same, so you don't get any advantage of saying, well, this is a deeper red in the color of this apple than others. Not true, okay? What happens when you have a perfectly competitive market is that each seller is going to have very limited control over price. At the extreme end, there's no control over price. So, market structure analysis. First thing, we're going to assume that firms want to make the maximum amount of profit they can. Now, in a perfectly competitive market, that can be tough, but that's still the goal. Any farmer who's worth being a farmer will tell you that he would like to make as much profit as possible. So we're going to concentrate, as I said, on this perfect competition, which is the purest form of competition. It is not like the competition that you see between car dealers where, the Ford guy and the Chevy guy would be perfectly willing to cut each other's hearts out and feed it to their dogs. Okay, world production of tea. Almost 10 billion pounds of tea. It's amazing. And I don't even drink tea. Coffee is even more because I drink coffee. So, the things that you look at with market structure analysis include the number of firms, the nature of the product, how easy or difficult it is to get into the industry and also to get out of it, because that can be important too. And then the extent that firms have control over price. So let me go back over those. Let me take a second, see what's going on. When you're ready, onward. The four main kinds of market structure are competition, which we're talking about now, Chapter 8, monopolistic competition, and oligopoly, which we'll talk about in Chapter 10. Monopolistic competition is like retailing. Think, retail shoe stores, women's shoe stores. Oligopoly is where you have only a few firms, usually very large, and they're all kind of looking at each other like, what's he going to do, and what should I do when he does, whatever. And then monopoly, which we'll cover in Chapter 9. It's a single seller in a market. All right, so what are the characteristics of perfect competition? Number one, there's lots of buyers and sellers, and every one of them is small in comparison to the total market. Number two, each buyer or seller has no control or influence on the price of the product. The biggest wheat farmer in the United States, if that person and his or her farm disappeared completely from the face of the earth, the total effect on the world market for wheat would be zilch, zero, nada, because they're too small. Even though they're very big in an absolute sense, they're very small relative to the total market. The firms in the industry produce what's known as a homogeneous or standardized product. There's really no difference between the wheat that one farmer sells and the wheat that the next farmer down the road sells. Buyers and sellers have all the information they need about prices, product quality, opportunities in other industries, and so on, in order to make informed decisions. And the last thing is, there's no significant barriers to entry or exit in the long run. If you think about electrical power and generating electrical power, if you wanted to do that with a nuclear power plant, there would be a huge barrier to entry because you'd have to scrape together several $1 billion just to start. And there are barriers to exit because you can't just walk away and leave the nuclear power plant sitting here with radioactivity all over the place. Okay, in perfect competition, because no firm has any control over the price, each individual firm is called a price taker. They just take the price that's set by the larger market, like the world market for wheat, as a given. They just have to react to that. Now, this means you can sell as much as you would like to sell at the going market price, but they can't affect the price by itself. And then there's another thing about this. When a firm sells more, that will not, as a result of one firm doing that, drive the price down in the market. Now, that's not true if all firms do that, but any one firm doing that would have no effect on the price of the product. Okay? Okay, remember the definition of total revenue from the chapter on elasticity. Total revenue is equal to the price times the quantity you sell. So here's what I mean by a price taker. Over in the diagram on the left, in class I drew this one on the right, but in the diagram on the left you have the industry, like the world market for wheat maybe, and a price of $200 at equilibrium, and the equilibrium quantity. So that $200 price then for an individual firm becomes, in a sense, it's like the demand curve, except that it's completely flat. Okay? So that means the demand curve, the marginal revenue, the additional revenue from each extra unit of the product, and the price are all the same thing. In this case, demand, marginal revenue, and price are all equal to $200. So you can produce Q1 or Q2 or any quantity, and you're never going to have an effect on the world market for this product, the industry market. So the individual firm takes the market prices given. MR stands for marginal revenue. Okay, in the short run, remember, one factor of production, one resource is fixed. That's usually the size of the plant. Doesn't have to be. And firms don't enter or leave the industry. Not in the short run. In the long run, yes, firms do enter or leave. In the long run, everything can change, like I said, including entry and exit of firms. When do they get in? When the industry is more profitable than other industries. When do they get out? When the industry is losing money relative to other industries. So this is just a checkpoint here. Make sure you understand what we covered so far. All right? More checkpoint, review of what we covered so far. Different market structures. The idea of price takers. Now let's talk about marginal revenue. This is the change in total revenue that results from the change of one more unit of a product. The formula is MR equals the change in, that's what that little triangle, the Greek letter delta, the change in total revenue divided by the change in the quantity sold. So it's extra revenue per unit. And, just think that the quantity sold could go up by 1. How much extra revenue would get? Well, if it's a perfectly competitive industry, that will be the same as the price of the product. Okay? Total revenue is price times quantity sold. That we covered earlier. So here's the rule. If you want to make maximum profit, you should produce at the point where the marginal revenue that you get from selling another unit is equal to that unit's marginal cost. Think about this for a second. If another unit adds more to your revenue than it does to your cost, you should go ahead and produce it, and then look at producing the next unit, and the next unit, and the next unit. If another unit added more to your cost than it did to your revenue, then you shouldn't produce that unit, and maybe you have to start thinking, well, what about the unit before that? Should I cut back? Should I cut back? Should I cut back? If marginal revenue and marginal cost are exactly equal, then you are at maximum profit. Whether you produce that unit or not won't really make any difference. What you don't want to do is stop short or go beyond. Now, if a firm at the point where they're making maximum profits is earning zero economic profits, remember the definition of economic profits? That's after you've covered all your costs. If a firm is earning zero economic profits at this point, then it's earning a normal profit. In other words, whatever it makes in accounting profit is just enough to cover all of its implicit costs. Does the accounting profits mean cover your explicit costs? Economic profits mean cover your implicit and your explicit costs. Okay, so here's the 5 steps to do this. Step 1, find the point where marginal revenue equals marginal cost. Find the horizontal line, whatever the price of the product is, and then follow that out to the right until the marginal cost curve hits it coming up from below. Okay? Step 2, once you find that point where marginal revenue and marginal cost are equal, then draw a vertical line down to the horizontal axis to find the right quantity. That's the profit maximizing quantity. Okay? Step 3, once you find that profit maximizing quantity, draw a line straight up to the demand curve. Okay? That's the price. And across to the vertical axis. Well, that's the profit maximizing price, but that's the market price. Step 4, using the profit maximizing output again, draw a line up to the average total cost curve and then across to the vertical axis to the left. Sorry. That's total cost per unit, or average total cost. The last step, find the amount of profit. It's a rectangle formed by the difference between the profit maximizing price and the average total cost, it's on the vertical axis, times the profit maximizing quantity, output, or on the horizontal axis. So there's going to be a graphic version on the next page. But one thing you should note, if economic profit is positive, in other words, you're not only covering all of your costs, but you're making even more than that, be aware that that's an incentive for new firms to come in here and start producing your product too. And that, unfortunately, is going to drive the price down. But we're getting ahead of ourselves. So there's the marginal cost curve, the average total cost curve, and the average variable cost curve. There's the price, marginal revenue. It's like the demand curve. That's where it hits marginal cost. So that's the quantity you want to produce. And to find that, drop that vertical line down from that point to the horizontal axis, the quantity or output axis. So in this example, that's 84, right? Second thing, find what your total costs are. Your per unit total costs are $180 per unit. Okay? Last thing is, look at the area between the price and average total cost and multiply it by the 84 units of output. So this is like the area of a rectangle that's 20 units high, from 180 to 200, and 84 units wide, and that's your profit. So, take a look at this. Total revenue is price times quantity. That's $200 a unit times 84 units, or $16,800. Total cost is per unit, or average total cost, times quantity. That's 180 times 84, $180 times 84, $15,120. The profit would be the difference between price, $200, and average total cost, $180. So that's $20 times quantity, 84. 20 times 84 is a profit, an economic profit, because remember, all of our costs are now in that average total cost curve. It's an economic profit of $1,680. So when price is equal to average total cost, then you're earning zero economic profit, or what we would say is you're earning normal profit. If the firms in an industry are only earning normal profits, if you're looking around for a new industry to get into, you're in some other industry and you're looking around for a new industry to get into, why would you get into this one? It's not doing any better than you can do anywhere else. So now you got to start looking for industries where they are doing better. So here's an example. There's average total cost, average variable cost, and marginal cost. At a price of $175 and maybe 75 units, then the firm is just covering all of its costs, its explicit or accounting costs, and its implicit or opportunity costs. So it's just covering all of its total cost, and its economic profit would be zero. Okay, now, we go back and make sure you understand that one. So the price of $175, all you're covering is your total costs. You're not making any economic profit. You are making an accounting profit that's equal to your implicit costs, but not an economic profit. Okay, so what happens if the price falls below average total cost? Go back to the graph earlier and say, what happens if the price is less than $175? Maybe that's because there's a temporary decrease in demand for the whole market for the product. So how do you react to that? The answer is that you're going to choose a strategy for minimizing your losses, whatever that means, whether it's produce less and operate at a small loss, or shut down in the short run and lose whatever fixed costs you have, but not more than that. Now, also note that economic losses that's like telling new firms, don't come here. This is a terrible job. This is a terrible business. It's a terrible industry. It's not sufficiently profitable. It's not worth it to get into this industry. Okay, when the price is below minimum average total cost, but above the minimum point of average variable costs, the firm will continue to operate at a loss. If the price falls below the minimum of average variable cost, then you just shut down and lose your fixed cost. That's the minimum loss you could take. Now remember something. Shutting down means you still have to pay your fixed costs in the short run. Exiting from the industry, getting out of the business completely, means that you sell off everything and just leave. And then in the long run, you don't have any costs in the future because you're not in that industry. So here's what happens. When prices fall below average variable cost, your losses, if you continue to produce, would begin to be larger than your fixed costs. So your shutdown point would be the price that's equal to the minimum point on the average variable cost curve. And then when you do shut down, your short-run losses are limited to whatever amount you have for total fixed cost. Here's an example. Average total cost and average variable cost. There's the marginal cost. If the price is all the way down to $160 a unit and a quantity of 60, if the price goes below 160, you should just shut down and lose your fixed costs. That would be a lower loss minimization, a lower loss than using that marginal cost curve, finding some quantity and producing it. Okay? So what's the short-run supply curve look like then? Well, it's the marginal cost curve. A supply curve shows how much a firm would produce at various prices, right? Well, if you go back to that graph here, it says the price is below 160, we won't produce anything. Once the price gets above 160, then we'll follow the marginal cost curve up to find the profit maximizing quantity. So what's going to happen is there's the average variable cost curve, there's the marginal cost curve, and everything above that, above the average variable cost curve, will be the firm's short-run supply curve. Okay? I have not read this novel, Makers, but I'm going to get it because physical products can be duplicated at basically zero marginal cost. That sounds like Star Wars or Star Trek, you know. Replicate a cup of tea, replicate a gold bar, no cost. Ooh, great. The point is that if this technology actually was available, you'd have to constantly come up with new kinds of products in order to capture any short-run profits before people could start duplicating it. It's going to be tough. Okay, so here's some checkpoints for stuff we've already covered. Marginal revenue, change in total revenue from selling one additional unit. Perfectly competitive firms are price takers. When we start talking about other kinds of market structures like monopolies and oligopolies and so on, then a better word for their behavior would be price searchers. Not necessarily makers, but searchers trying to find the best price. Competitive firms don't need to worry about finding the best price. It's right up there at whatever the world's market price is. And you maximize profits by producing output up to the point where marginal revenue equals marginal cost. MR equals MC. If the price is greater than average total cost, you earn profits. If it's below average total cost but above average variable cost, you keep operating, but you earn an economic loss because you don't cover all your costs. The price falls below the minimum point on the average variable cost curve, just shut down. So the short-run supply curve is that marginal cost curve above the minimum point on the average variable cost curve. Okay, long-run adjustments. What happens if firms in an industry earn short-run economic profits? You know what happens. New firms may enter the industry and, or you can do it either way, and you can do it both ways. Existing firms may increase the scale of their operations. On the other hand, if you're earning losses, if firms in an industry are earning short-term losses, some firms are going to get out because losses tell you you can do better somewhere else. And that's exactly what's going to happen. So in long-run equilibrium, the price will be equal to average total cost. And here's what happens. There's the industry supply and demand curves. That gives you a particular price. And then at that price, the firms produce their equilibrium quantities, their profit maximizing quantities. Add up the output of all those firms, you get the industry's output. So in long-run equilibrium, economic profit will turn out to be zero for the firms in the industry. Not in the short run necessarily, but in the long run. Because as soon as you start making profits, new firms come in and start competing those profits away. And the market will produce the maximum possible producer and consumer surplus. Consumer surplus in the industry diagram there on the left would be the green triangle. Producer surplus would be the tan triangle. Okay? So what about the public interest? Does this actually help us? Well, think about what happens if we're at a long-run equilibrium. We will be productively efficient because everybody in the industry has an incentive to use the most efficient technology they can to produce at the lowest cost way they can, because that's what gives them more profit. Now, the catch is that if there's a way to become more productively efficient, maybe a new technology or something like that, then other firms in the industry, because remember there's good information about what people do, other firms in the industry will come in and do the same thing and compete those profits away. Productively efficient means we produce things at the lowest possible opportunity cost. Allocatively efficient, economically efficient, means the market is directing resources to the goods where they're most highly valued. And if we have a market where goods are really highly valued and entry and exit is relatively easy, then firms will move into that market as soon as they see economic profits being made there and compete those profits away. Okay. In the long run, here's what happens. If there's an increase in demand, let's just deal with that. There's an increase in demand for an industry's product. So firms in the industry expand and new firms come in. If this new demand for raw materials, labor, all the inputs used in producing this product cause prices for those inputs to go up, then you get an increasing cost industry. And what that means is initially the increase in demand will lead to higher price, and then firms react to that by producing more, and new firms react to that by coming into the industry. But when they do that, that starts to affect profits in two ways. First of all, for existing firms, it pushes profits down from the top because it'll push the equilibrium price down in the market. And secondly, it'll reduce profits from the bottom because it drives costs up. In that case, the long-run supply curve would look like an upward sloping line if it's an increasing cost industry. Now, here's an example of something that's reduced costs. Standardized shipping containers. Have you ever seen a cargo ship that carries containers? Just called a container ship. Truly amazing. These things carry thousands of containers. And the nice thing about them is you really cut down on things like pilferage and losses when you use these. 40-foot container, 32 tons of cargo, shipped from China to the U.S., costs $5,000. That's 7 cents a pound to haul it all the way across the Pacific Ocean. So globally, a lot of industries that weren't necessarily very competitive in the past have become more competitive, partly because of stuff like The Box. It's a very interesting book called The Box. If you get a chance, read it, because it talks about some of the implications of what these little metal containers have done. Okay, decreasing cost industry. If economies of scale actually happen because more firms enter, then what could happen, right? Raw material suppliers enjoy economies of scale as the industry demand for their product increases. Semiconductor is a good example. Because there are economies of scale in making semiconductors, demand increases have actually resulted in lower prices, partly because of economies of scale and new technology. If that's true, let me go back here for a second. If that's true, then the long run supply curve actually is downward sloping if it's a decreasing industry, decreasing cost industry. The last thing is a constant cost industry. And usually this could happen in an industry where there's virtually no effect on input prices if firms buy more. So if you think about the market for pencils, well, wooden pencils actually have a brass fitting on the end of them. And that brass fitting, sometimes it's aluminum, usually it's brass. That fitting is one of the uses of copper. But come on, how many people use wooden pencils with little brass, they call them ferrules, little brass ferrules on the end of them with the eraser? Nowadays, if you use a wooden pencil, it's like, well, what do you got? Something against technology or something? Why don't you use a word processor? But if there was an increase in demand for pencils, that would probably have zero effect on the world price of things like copper. With a constant cost industry, what you get is a flat long-run aggregate supply curve. Okay? So you get a series of checkpoints. In the long run, industries will either be increasing cost, decreasing cost, or constant cost. And then market structure includes things like how many firms, nature of the product, standardized or differentiated, barriers to entry, individual firms' control over products. Perfect competition, everybody produces a nearly identical product, so each individual firm is a price taker. Can't control the market price. Produce the output where marginal revenue and marginal cost are equal. And if producing at the point where price equals average total cost, then economic profit is zero. In the long run, what happens is firms basically get pushed down to the bottom of their long run average cost curves. Why is it efficient? Gives us the goods we want at the lowest possible opportunity cost. There's a series of discussion questions here. If I get a chance, what I will try and do is write answers to these and then put these up maybe in a separate document, maybe in this document. We'll see what happens, so that you can see if your understanding of these discussion questions matches up with the correct answer. Okay? That's it. Thanks a lot, everybody. Hope you enjoyed it.